All right, great. We have some data now. A researcher randomly selects 6 fathers who have adult sons and record the father's and son's height to obtain the data below. Determine if the sons are taller than their fathers at an alpha zero point 0.1 level of significance. So we're assuming normality assumptions are satisfied. So let's just open this data in StatCrunch. I'm going to close this down. Okay. So we're going to use father's height minus son's height. We want to see whether sons are taller than their fathers. So here's our data. We're going to be, since we have fathers and sons, we're going to pair them together. So under stat, we're going to do a t-stat, not two sample, but paired. And here I'm going to, my first column is the height of fathers. Second sample is height of sons. And I'm going to, let's click Save Differences just for fun. It'll create a new column of differences. It's not strictly necessary. Now the null hypothesis is that the difference of means is 0, but the alternative is that the difference of means is what? We want to see if the sons are taller than their fathers. That means father's height minus son's height should be negative, less than 0. If the son's mean is bigger than father's mean, mu1 minus mu2 should be negative. So that's the alternative we want to pick. Now I want to click Compute, and I want to show you one thing that just popped up. This new column of differences was created. So really what was done was a one sample t-test on the differences column. That's all a paired sample test is. You just calculate the differences and you do a one sample test on the differences. But this allows us to do it all in one fell swoop. At any rate, we've got a p-value of 0.1075. That's just over my my alpha level of 0.1. If we were to go to the calculator for the t-distribution, and for a left tail test with 0.10 in the tail, and degrees of freedom of, what did we have here? It says degrees of freedom is 5, so I'll put in 5 for the degrees of freedom, and I'm going to click Compute. This is telling me that the cutoff, the critical value, is negative 1.475. So I would only reject if the t-statistic was less than that cutoff out in the rejection region, but it's not. So I do not reject because t naught is greater than t alpha. T naught is my test statistic, t alpha is my cutoff, my critical value. Okay, we could have, of course, concluded that based on the p-value of 0.1075 being greater than my alpha level 0.1. Same thing, same conclusion, just a different way of looking at it.